All right, let's get right into it. If you've ever built anything with a large language model, you know that amazing aha moment, right? The first time you get a really complex task to work, it just feels like pure magic. But then, you run it a second time, and it fails, or it hallucinates a step that doesn't exist, or it just gives up. That feeling of building something that's brilliant but also incredibly brittle, that's the chaos. And today, we're going to lay out the blueprint to turn that chaos into control.
So yeah, how do we fix this? How do you build an AI that can actually handle those complex multi-step jobs and not just work once, but work every single time? I mean, that's the real challenge, isn't it? We want these agents to do more than just answer a simple question. We want them to run entire workflows, to plan trips, to be real assistants. But that unpredictability, that's the wall we all seem to hit.
And here's the secret. This is the thing that separates a cool little demo from a real production-ready app. The answer isn't just throwing a bigger, more expensive model at the problem. And it's not about tweaking your prompt for hours on end. It's about architecture. It's about using a smarter design pattern. That's the blueprint we're talking about. And in this explainer, we're going to walk through 3 fundamental patterns that'll give you the control you've been looking for.
Okay, let's kick things off with pattern number 1, the single agent. Now, this is the default setting, right? It's where we all start, and honestly, for a pretty good reason. It's super straightforward. Think of it like this. You've got one really smart, really capable employee. You give them a giant to-do list and a whole box of tools. You just write one big, detailed prompt, hand it over to the model, and then you kind of cross your fingers and trust its own internal logic to figure out the right steps in the right order.
So for example, you could ask it to plan a trip to San Francisco. A single agent just takes that whole request, grabs its search tool, and tries to do everything all at once. It's looking for flights, hotels, maybe some tourist spots, all in a single pass. And you know what? For a simple query like that, it can actually work surprisingly well. But the second you add any real complexity, well, that's where the cracks start to show.
And this really lays out the trade-off perfectly. On one hand, yeah, the single agent is simple to get up and running. But on the other, it's basically a black box. You have almost zero direct control over its thought process. So when the task gets just a little more complicated, like find a late-night sushi place and then find the fastest way to get there, the model can easily get lost. It might just forget the second step or do them in the wrong order. So here's the takeaway. Its greatest strength, its simplicity, is also its biggest weakness. You're trading control for convenience.
So to get that control back and build something reliable, we need to add some structure. This brings us to our second pattern, the sequential agent. And a great way to think about this is like building a specialized assembly line for your AI.
So instead of one generalist agent trying to juggle everything, you build a chain of specialists. Each agent in this chain has one and only one highly focused job. They run in a fixed, predictable order that you define. And here's the most critical part. The output from Agent 1 becomes the direct input for Agent 2, which then feeds into Agent 3, and so on down the line.
Let's go back to that sushi trip. With a sequential pattern, you'd build 2 separate specialist agents. First up, a food-finding agent. Its only job is to find a good sushi spot. Once it finds the address, and only then, it passes that information to the transportation agent. And that second agent's only job is to take an address and figure out the best way to get there. There's no confusion, no missed steps. It's a perfect 1-2 punch.
Now you might be wondering, how does that handoff actually happen? Well, it's not magic. It's a cool mechanism called a shared scratchpad, or sometimes session state. Just think of it like a temporary clipboard. Agent 1 finishes its job and writes the restaurant's address to the scratchpad. Then Agent 2 kicks off its job by reading that same address from that exact same place. It's a really simple but incredibly powerful way to give your system some short-term memory.
The upside here is huge. You get a ton of control and predictability. The process runs exactly the way you designed it, every single time. But, there's no free lunch. You're trading flexibility for all that control. The structure is pretty rigid. And maybe more importantly, it can be slow. Each specialist agent has to just sit there and wait in line for the one before it to completely finish its work.
So what if you need that control and reliability, but you just can't afford to wait? What if some of your tasks don't actually depend on each other at all? Well, that brings us to our third pattern, the parallel agent, which is all about one thing, unlocking maximum speed. The logic here is just beautifully simple. If a bunch of tasks aren't dependent on one another, why on earth would you make them wait in line? The parallel pattern just unleashes multiple specialist agents to work on different parts of a problem all at the same time. It's about concurrency instead of sequence.
Let's go back to our trip planner, but let's make it a full day out. Finding a museum, finding a concert, and finding a restaurant. Those are 3 totally independent jobs, right? You don't need to find the museum before you can start looking for a concert. So with a parallel pattern, you can just spin up a museum agent, a concert agent, and a restaurant agent, and have them all get to work at the exact same time.
Of course, once all those agents find their results, you need a final step to pull it all together. And this is where things get really, really powerful, because you can start combining these patterns. You can build a hybrid system. So, step 1, run the 3 searches in parallel to get the answers as fast as possible. Then, step 2, feed all 3 of those results into one final sequential agent. We can call it an aggregator agent, whose only job is to synthesize everything into a single cohesive itinerary. You get the speed of parallel with the reliability of sequential. It's really the best of both worlds.
So the number one benefit here is a massive reduction in latency. That's the total time the user has to wait. It's just way more efficient. The trade-offs? Well, it can have a higher initial cost because you might be running multiple LLM calls all at once, and like we just saw, it almost always needs that final synthesis step, which, adds a little bit more complexity to your overall design.
So there you have it. In just a few minutes, we've gone from a single, unreliable worker to a super efficient multi-agent workflow. We've literally gone from chaos to control. Let's just put it all together on one screen so it's crystal clear.
And here it is, your official cheat sheet for building better AI agents. So, stick with the single agent for those simple, one-off tasks where you just need to get it done easily. Choose the sequential agent when you absolutely need rock-solid reliability for a structured, repeatable process. And you're going to deploy the parallel agent when speed is everything, and the task can be broken down into independent pieces. See, it always comes down to that trade-off between simplicity, control, and speed.
The real power here isn't just knowing these patterns exist. It's knowing which one to use for which job, and maybe most importantly, knowing how to combine them. By moving beyond just a single massive prompt and starting to think in terms of these structured designs, you can build systems that aren't just more powerful, but are fundamentally more reliable and more robust. So you've got the patterns. The only question left is, what will you build with them?